A rare and mysterious object from beyond our solar system has recently captured the world's attention. New images have surfaced online, allegedly showing a close view of 3I Atlas taken from observatories in China, while several posts claim that Western telescopes have quietly stopped releasing their own photos. In this video, we'll try to uncover what's actually true. But if China's telescopes manage to capture what others couldn't or perhaps wouldn't, what exactly are we not supposed to see? What is 3I Atlas? 3I Atlas is an interstellar comet. Astronomers gave it several names. The survey name is Atlas, and the formal designation is C/2025 N1. The discovery was reported by the Atlas Survey Telescope at Rio Todo in Chile on the 1st of July, 2025. Observers confirmed that its orbit is hyperbolic. That means it came from outside the solar system and will leave again. Scientists say 3I Atlas is the third known interstellar object after 1I Oumuamua and 2I Borisov. Its path brings it closer to the Sun than Borisov's did. That makes it easier to study the gas and dust that comes off the object. Early images showed a fuzzy coma of gas and dust around a bright center. The coma is the cloud of ice and dust that vaporizes as the object warms. Size estimates vary. Observers using Hubble, the Vera C. Rubin Observatory, and other instruments report different ranges. Current estimates place the nucleus somewhere between a few hundred meters and several kilometers across. Some analysis gives an upper limit of about 5.6 kilometers. Other observers find much smaller numbers. The difference comes from how bright the object appears and assumptions about surface reflectivity. Those details will be refined as scientists gather more data. The groups that observed it include Hubble, the European Southern Observatory with the Very Large Telescope, Gemini South, the Vera C. Rubin Observatory, and space missions such as SPACERX and ExoMars. Researchers used visible light and infrared instruments. Spectroscopy showed gas and dust in the coma. The object moves very fast, over 130,000 miles per hour, which makes close study challenging but possible when many telescopes coordinate their observations. Hubble took one of the sharpest images on the 21st of July, 2025, and helped researchers set a size limit. The Atlas team filed early orbit solutions with the Minor Planet Center. Other groups found recovery images in older survey data. Observatories in North America, Europe, and Asia added tracking. Scientists shared data through email lists and the IAU Minor Planet Center. That network helped confirm the interstellar nature quickly. Observations continued through October and then into November. But before anyone truly understood what they were tracking, one question loomed: where did this strange interstellar visitor actually come from? The Atlas Survey Telescope at Rio Todo, Chile, first flagged the object on images taken on July 1, 2025. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. The Atlas Discovery team posted the position to the Minor Planet Center and to the wider astronomy community. The next step was followed by larger telescopes. Observatories such as the European Southern Observatory with the Very Large Telescope, the Gemini South Telescope in Chile, and the Vera C. Rubin Observatory in Chile pointed at the location to get more detail. Hubble then took high-resolution images. Those images helped them estimate the size and structure of the coma. Hubble data gave one of the best early looks because the telescope is above Earth's atmosphere and sees fine detail. Ground telescopes filled in wider coverage. The Rubin Observatory provided deep images that showed the object before its reported discovery. Those earlier images are called precovery images. They extend the observation arc and help refine the orbit. Spectrographs at many facilities measured light from the object. Spectra reveal which gases and dust are present. Early spectra showed common comet gases and dust signatures. Some scientists noticed strong water vapor signals and other molecules. Researchers calculated that the object was shedding material at a high rate while it warmed. Those measurements came from a mix of ground telescopes and space observatories. Scientists coordinated their plans through formal networks. The International Astronomical Union and the Minor Planet Center helped share times and coordinates. Observatories posted observation windows so multiple groups could plan. Space assets such as the SPACERX mission and the ExoMars Trace Gas Orbiter also joined the effort. SPACERX provided infrared scans, and ExoMars aimed its CASIS camera toward the object when it passed near Mars. Data came quickly and in many forms. Images showed shape and brightness. Spectra revealed the composition. Photometry tracked changes in brightness over time. That mix of data lets researchers test ideas about size, mass, and activity. They published early results as short notices and posted data to public archives. The rapid sharing of data allowed other scientists to check results and to propose new observations. The follow-up stage is still active. New images and spectra arrive as instruments continue to observe. Each dataset helps reduce uncertainty. In short, discovery by Atlas began a global campaign. The result is the best early record yet for a rare interstellar visitor. The closest images of 3I Atlas so far came from a Mars orbiter. On the 3rd of October, 2025, the European Space Agency pointed the ExoMars Trace Gas Orbiter toward the sky near Mars and recorded a series of frames. The camera used was CASIS, the Color and Stereo Surface Imaging System. The images show the object as a small, slightly fuzzy white dot moving against streaks of background stars. The frames were combined to make an animation that shows motion. The images are not sharp enough to show a solid nucleus. ESA described the observation as the closest view yet because ExoMars flew nearer to the object than Earth did at that time. The probe saw the object against the star field near Mars and captured a short sequence. The ExoMars images made a rare case where a mission designed for Mars science photographed an interstellar visitor. The images landed on public servers and on ESA social feeds, where journalists and scientists reviewed them. Hubble provided early high-resolution images in July. Hubble images showed a teardrop-shaped glow and helped set upper limits on nucleus size. Hubble team frames helped astronomers study the coma shape without atmospheric blurring. Ground telescopes such as the Very Large Telescope and Gemini South supplied complementary views with wider fields and different filters. The Vera C. Rubin Observatory produced deep images that were. Space observatories added data in other wavebands. SPHERX performed infrared scans that measured brightness at longer wavelengths. Infrared data help estimate dust and ice content. Combining infrared and visible observations gave them a fuller view of the object and its activity. Photometry from many sites tracked changes in brightness over days. Scientists used that sequence to model how much material the object lost as it warmed. One clear result is that 3I Atlas shows activity consistent with comet behavior. Observations show gas and dust flowing away from the nucleus as sunlight warmed its ices. Some scientists measured water vapor and other molecules in the coma. Estimates of mass loss vary but point to substantial activity. The activity level changed as the object moved closer to the Sun. Observers noted spikes in brightness that matched increases in gas release. ExoMars images showed no clear tail in the frames from the 3rd of October. The lack of a visible long tail in those images reflects the camera's limits and the faintness of the extended dust. Ground telescopes, when conditions allowed, recorded longer, fainter tails in deeper exposures. The exact shape of the tail varied with viewing angle and observing wavelength. Observers also saw an antitail in some images, a feature that depends on the geometry between the Sun, the comet, and the observer.